So we're looking at another example, but this example, we're looking at finding the area under the curve. Instead of using the rectangles like we were doing, we're going to try to find and use other facts we know about areas. And so in this case, we can tell what our function is that we want to look at the area. That is your integrand. So that is f of x is equal to the square root of 16 minus x squared. I'm actually going to write this as y for a second so that you can see what that graph will look like. And we're looking at this from the bounds. We're looking at the area between our x value -4 to our x value of 0. So if we square both sides of this equation really quickly, we would get y squared is equal to 16 minus x squared. If I add x squared to this, to both sides, notice I get x squared plus y squared equals 16. So I can tell right here that this is a circle, because this is in the form where I can tell what the radius is and what the center is. This is a circle centered at 0, 0. And this is a radius of 4. The thing is that this was positive. So this is actually the upper half of a circle that's centered at 0, 0 with a radius of 4. Okay, so my units, it's not going to look like a total circle or semicircle because of my units aren't equal. You get the idea. And it had the bounds again from -4 to 0. So it wants us to find the area in here. So really, we're trying to find the area of a quarter circle. So let's look at the area of a circle. We know the area of a circle is equal to pi r squared. So an area of quarter of that circle is going to just be pi r squared over 4. But we know what r is, right? Our radius is 4. So if we plug in 4, we can see that this area is equal to pi times 4 squared all over 4. Or the area, well, that's going to give me 16 over 4, which is 4 or 4 pi. So we use known facts of how to find area of certain shapes, and we could do that in this case to find the exact area or that definite integral from -4 to 0 without having to go through that limit as n goes to infinity of that summation of all the rectangles. So the next example says, well, they want us to graph the integrand and use the known area formulas to evaluate the integral. And so in our example, next example, we have the integral from -1 to 1. And we have our function, our integrand is the quantity 1 minus the absolute value of x. and then dx. And so here you can see that our function f of x is equal to 1 minus the absolute value of x. I'm going to use the fact of translations and knowing the shapes of graphs to look at this. And so I noticed that if I had y equals the absolute value of x, that's the V shape, right? But if I have y equals and there's a negative in front of it, well, in order to get that, I have to change my y value. So that's a reflection across the x-axis. And then remember that so this could be written, if this helps you, as negative absolute value of x plus 1. And so the constant outside is what our shift. So we're shifting this up 1. So if I graph this, you notice I have a V shape. I shift it up 1. And notice that this is actually crossing the x-axis, right? -1 and 1. This is telling us we want to find the area between -1 and 1. So we basically have this rectangle, right? I know what my height is, and I know what my base is. So we can do it with rectangles. So an area of a rectangle is 1/2 times base times height. So the area for us here is 1/2 our base. That length is -1. Well, that is 1 here plus 1 or 2. And our height is 1. So this area is just 1.